Hi, I'm sorry you couldn't make it to class today. I just wanted to make this little presentation to go over some of the things that happened while you were gone. So in class today, one of the first things we did was we came in and reviewed Friday's work on density, and we went over all the problems for the Part 2 worksheet that aligned with 3.09 in Canvas. So last week on Thursday and Friday you should have done 3.07, 3.08, and 3.09. And you should be able to calculate density, mass, and volume. Given if you have two of them, you should be able to figure out the other one using the density triangle. So we went over those problems a little bit, and we went into this presentation. We started talking about density and how that relates to concentration and why it's important for your project. We looked at density on the left side of the screen as being the amount of something inside a specific amount of space. And then concentration is a little bit different of that because it is the amount of something inside of a mixture, inside of something else. So as we can see on that right side, we have little orange dots, and those are the things we can describe by concentration. Okay, we can describe how many of those are in a certain volume of water. So right there we have 13 orange dots, so we could say that there's 13 orange dots for every 50 milliliters of water. And that's a concentration. We're describing how much of something is in something else. Concentration uses the same units really as density, in that it's going to be mass over volume, and density is mass over volume. So there's no real difference in the way that we're going to calculate it. It's just we're talking about something inside of another substance instead of talking about a single substance and how much is inside of it. So we're going to do this problem really quickly. A student dissolved 10 grams of sodium in water to make a solution with a volume of 90 milliliters. What is the concentration of sodium in the solution? So we have mass divided by volume. We know that 10 grams is a mass. That's how much sodium we put in our water. And that the volume total was 90 milliliters. So 10 grams divided by 90 milliliters is going to come up 10 grams per 90 milliliters would be the concentration. If you divide 10 by 90, you get 0.11. So you'd have 0.11 grams per milliliter of sodium. So 10.1 or 0.11 grams of sodium for every 1 milliliter of liquid, of water. So that's a concentration. We're talking about how many grams of sodium is in every milliliter of water. And that's the difference, and that's what we're going to be talking about when we talk about how much dissolved oxygen is in water, how much nitrates are in water. So the units of concentration can look a lot like mass over volume or grams over milliliters, and there's also one other way that can say concentration. If the amount of something is trace, or it's so small that it's too hard to describe by mass over volume, sometimes science will state it as ppm, or parts per million. And that simply describes out of every 1 million parts, how many of those parts are identified as the substance that you're looking for. So we might say that 10 parts per million, we have 10 parts of sodium for every 1 million parts of the water that we're testing. So every 1 million milliliters of water, maybe 10 of those milliliters would have sodium in it. So we're just describing like almost to the millionth as a fraction how much of one thing is in a substance. And then we talked about dissolved oxygen, and if there's so much air above the water, then why isn't there, this is the air above the water, if there's so much air above the water, then why is it more oxygen forced into the water? Because we talked last week about the more that's above will get forced below until it evens out. Well, if there's so much air, you got to think about from the ground all the way to outer space. If there's so much air, then why isn't there more oxygen below the surface of the water or in the water? And it really comes down to that, let's say all these blue ones are oxygen and all the green ones are the rest of the air. Oxygen, or our air is not entirely made of oxygen. Some of it's made of other things. So only a little bit of that's oxygen, and that does try to balance out with what's in the water. And we looked at the nitrogen being that these other green particles that you saw up in the air here on this slide, which is about 78% of all the gases in our atmosphere. Oxygen is only actually about 21% of our air. And then about 1%, depending on where you look, is made up of other things. So water vapor and CO2 and some other gases that we won't talk about yet. It's very important that you know that. After that, we went over and we took a look at this. And I need you to try to come up with your own about which of these people are correct. If 5 friends were looking at a large white puffy cloud in the sky, they wondered what the clouds were made of. This is what they came up with on their own. This is what Trista, Lee, Manny, Rosie, and Eric thinks. If you could pause this video really quickly and take a look at it and see what who you think is correct. Okay, I hope you've unpaused and are now reading this after you made your selection. Most of these are somewhat correct. The one who is the most correct is Eric, that thinks clouds are made up of both tiny drops of water and other particles. If you'll notice, when condensation happens on your glass, when you take a cup of ice water outside in a summer day, the water droplets don't form around the glass and the air and then fall out of the sky. The water droplets form on the glass. So there has to be tiny particles, pollutants or smoke or other particles of something in the air for those water droplets to form on in order for those to condense and make clouds. So we just wanted to talk about that really quickly before we moved on and make that connection to the water cycle. There will be a quiz over everything we've learned through the water cycle, all the way through calculating density and how that relates to concentration. Please let me know if you have any other questions.